Enjoying a well-deserved time away. As most of you are aware now, earlier today, Michael Collins' family announced his passing. We'd like to take just a moment to recognize his historic life and contributions to space sciences and STEM education. At this time, we'd like to also then announce that our center has posted the registration for our virtual camp programs. They're offered this summer virtually. The Micronaut Movers Camp is designed for children who have completed kindergarten through second grade, while the Space Station Adventurers Camp is for crew members who have completed third through fifth grades. You'll find the links for these camps and other resources for the summer located on our website, and we'll share them in the comments on both Facebook Live and YouTube, where we're sharing the programs this evening. The Scobie Education Center has been hosting the virtual version of this global meeting of minds since the pandemic descended upon us, and we're thrilled to be able to provide this support for such a worthwhile endeavor to promote the studies of our world and the neighborhoods in which we revolve. Astronomy on Tap San Antonio is a monthly event where one or two scientists give about 15-minute presentations on the space-related topics they're passionate about while you drink it all in. Originally, these were held at the Blue Star Brewing Company and will continue in this virtual realm at least until June, when it's hoped that the conditions will permit us to return in person to those programs at Blue Star once again. The coordinators of Astronomy on Tap in San Antonio are Tracy Becker and Vincent Yu, who are both scientists at Southwest Research Institute. Our speakers this evening will be Dr. Rachel Philwitt and Frederick Allegrini. And our very first speaker tonight will be Dr. Rachel Philwitt, and her program is entitled Energetic Particles and Their Ability to Access the Earth's Magnetosphere. Rachel is a postdoctoral research scholar at the University of Iowa. She was awarded a National Science Foundation Atmospheric and Geospace Sciences postdoctoral research fellowship to study the entrance of solar energetic particles into the Earth's magnetosphere. Her research interests are in ion particle acceleration and transport, and she's particularly interested in energetic particle entrance and effect on both the terrestrial and the gas giant magnetospheres. She's also interested in developing the next generation particle instruments that can be miniaturized for use on CubeSats while still providing top-of-the-line mass and energy resolution. We invite you to add your questions and comments to the comment features on both Facebook Live or YouTube, and we'll be working with our team of Scobie technicians to monitor these areas so that we can get these questions to Rachel following her talk, and then again to Frederick later following his talk. Rachel, you have the helm.
Thanks so much, Rick. And that was such a kind introduction. It's great to be virtually back in San Antonio. I did my graduate work at UTSA in partnership with the Southwest Research Institute. And so it's great to be virtually back with all of you. Yeah, so I'm going to talk about a topic that I'm really passionate about, space weather. And so changed my title a little bit. So I'm calling it Cloudy with a Chance of Protons. So little play on our weather format here. So just like in the book Cloudy with a Chance of Meatballs, I'm going to talk about some really unconventional weather and maybe how we can predict it a little bit. So first, what is space weather? Hopefully, some of you have maybe heard about it, know maybe a little bit, but even if you've never heard about it before, I hope we all walk away knowing just a little bit more about it and how it affects our daily lives. So first, our planet and lots of other planets are surrounded by magnetic fields. And this magnetic field is the same one that helps your compass point north. And it turns out magnetic fields are pretty important to protect us from stuff coming at us from the sun. And the sun, with all its wonderful light and warmth, also produces a lot of other things, such as really energetic particles, which could be protons and electrons, and then what we space physicists call heavy ions. And we do, in fact, call anything heavier than a proton a heavy ion. So it's a pretty low bar. But what's most often associated with solar activity is solar flares and something called coronal mass ejections. And these are basically massive explosions on the surface of the sun, which send light and energetic particles flying away out towards the planets at over 600,000 miles per hour. These particles are accelerated in solar activity, which varies with something called the solar cycle, just like seasons on Earth here vary. But the sun's activity isn't a year long, it's 11 years long. And this activity cycle means that the way the sun impacts the space around it, including here on Earth, is constantly changing. Just like Earth weather, sometimes the forecast calls for sunny days and everything's calm and wonderful. And sometimes, rarely, there are some catastrophic events, such as hurricanes or tornadoes. These variations in how they affect the Earth and the human space-based assets, such as astronauts or satellites, and predicting them is what we call space weather. So what does space weather affect? So I'm not an astronaut, you're not an astronaut. Well, maybe, but that would be cool. Say hi. So these things happen in outer space, and why should we care? But really, when you stop and think about it, many things in our everyday life are linked to things in the atmosphere or satellites. And so I've listed some of the things here on this slide that space weather really affects. So it can create radiation hazards for astronauts. There can be electric interruptions or shutdowns for spacecraft. And it can increase the drag on satellites. And so that means that they have to use more fuel and adjust more often. There can also be increased radiation for planes and the passengers on them. There can be GPS signal errors. So this is really important for the Department of Defense, for farming. A lot of tractors these days, they find their way by these GPS setups. And so it's really important to get the most out of your crops. I'm in Iowa, and so that's really important to us. And even something everyday like, say, Google Maps. And then there could be induced currents in power systems, or even worse, you could fry the transformers and lose all power in a certain area. And then there's also currents in different cables and pipelines. And so these can be really damaging to systems. So I'm going to tell you about the space weather version of like a Category 5 hurricane. So in 1859, there was this very large solar energetic particle event called the Carrington event, observed independently by two different people. And one, unsurprisingly, was named Richard Carrington. So it's named after him. The poor other guy didn't get it named after him, but here we are. So he observed this white light flare on the surface of the sun. And this flare was associated with these strong coronal mass events that I brought up. So it went out into space and it hit the Earth's magnetic field. And it was so strong that the northern lights were seen as far south as the Caribbean. There were telegraph systems that sparked. Gold miners in the Rocky Mountains allegedly woke up because the sun was so bright they thought it was daytime. They began to make breakfast. So what if this happened today? I mean, this was in 1859, and so not a big bunch of technical infrastructure. So if this happened in 2013, the estimate would be somewhere between 4 to 15% of our annual GDP that it would cost us. And so that's huge. But obviously we haven't had something this big since 1859. And so what are the real chances of something like this happening? Well, just like there's a range of bad weather on Earth, there's a range of bad weather in space. So this 1989 storm knocked out power to sections of Quebec. And in 2012, the Earth just narrowly missed a Carrington class event by just a few days. And so the threat is real. So let's get into the science of this a little bit. So what does this actually look like? So here on this blue screen, there should be an image playing. So this white small circle in the center is where the surface of the sun is. And we have the center darkened, so you can't see the actual sun itself. Let's play this video again. So you see these explosions of particles coming off the sun, and these are these coronal mass ejections. And in one of these mass ejections, you can have about 1 billion metric tons of mass. And so these are really large events that then expand as they go out into the solar system. Let's see. Yeah, so if the CME comes towards Earth, some of these particles can then enter Earth's magnetic field. And this green dot that you should see moving around represents a particle that came off of a solar flare. So what it does is it can bounce around in Earth's magnetic field, and maybe it collides with our little satellite here. Maybe your favorite satellite. Maybe it's a communication satellite or GPS or, something more attached to the military, which can be really damaging. So it's not always that these particles will take out the satellites, but they can really degrade them a lot faster or cause these kind of single interruptions. And so we really want to be able to predict these events so we can avoid any satellite interruption at all. So then how do we predict it and prevent it? So you need to understand the physical system, which is what I'm interested in doing, and so many other great scientists. So we have all these models and observations that feed into our prediction capabilities, and this is a constant place of growth. We're always looking to understand the system better. But it's also really important to national security and commerce, as I mentioned. And so the National Weather Service actually has a space weather prediction center called SWPC, and they look at different images of the sun, and knowing all the different physical processes, they're able to predict a little forecast. And I just grabbed this forecast earlier this afternoon, and it looks like the next couple of days are going to be really quiet, which is not surprising because the sun is in a pretty quiet and calm phase of its cycle, of its seasons. So we're able to prepare for these events by building some mitigations in place. So along with our predictions, you also build in ways that you can kind of divert power if you need to, or shut systems of the satellite down, and you build in extra defenses to protect against these radiation. But you really need to understand how big the risk is in order to effectively prevent against it. So just quickly, what's my very small part in this? So as you probably guessed, I'm really interested in these energetic particles and how they go into Earth's magnetic field. So it's just a drawing of kind of how they access and what it looks like. It's a simple model of it. And lots of studies have looked at access via the polar caps. And that's because the magnetic field there makes it easier for particles to access lower altitudes. But I'm really interested in these equatorial regions, which is where we have a lot of our called geostationary satellites. It's also where a lot of our communication satellites, some GPS exist. And so I'm really interested in calculating and using models on how these particles enter here. And so that's my small part, and thanks to the NSF for funding this, what I find to be very important work. And then just wrapping up, of course, every storm has a silver lining. So these beautiful aurora, some pictures here in this video from the International Space Station, these aurora are caused by these storms and can get really large and can move to lower places on the planet, maybe down to Texas in a huge storm. And so these are just beautiful things to witness, and a very great silver lining to these storms. So yeah, thanks so much for learning a little bit about space weather with me tonight.
Do we have any questions from our viewers that are on Facebook or YouTube? We're looking for those to come up. There may be just a slight delay there as we're waiting for those. I seem to recall historically there was something called the Great Halloween Storm, like 2003 or sometime around that time period.
Yeah, I think you're pretty close to right on there. It was kind of in the early 2000s. So that was a very large event. It wasn't quite a Carrington class, but it was pretty severe. And so it is kind of what we look at as kind of the modern bad event. And so you can go and look at what sort of systems interruption took place then. But even since 2003, I mean, how many more satellites do we have up in there, and how much more reliant are we on consistent internet, consistent power, things like that? We're sending more satellites up nearly every day, I think. And so understanding space weather is even more important today than it was back then. And as the sun wakes up and we look for it to be the most active, we think it'll be probably 2025. That's when we start to really worry about all these new assets that we have up in space.
When the different agencies predict solar storms, do they actually change the routes of planes along the polar regions?
Yeah, so for a major solar storm, you can get polar routes diverted because that's where you really worry about the radiation. And so these large polar flights are usually the flights that are going the farthest. And so that can be really expensive for airlines. And so it's important to, first of all, be able to accurately say whether or not that is a radiation risk, because you don't want people to be exposed to more radiation than they need to be. But also, I mean, the airlines have to make this calculation of how much more fuel are we going to spend? Do we have to make extra stops? What's the possible delays here? And so there's a big importance to first get the prediction right, and then the individual commercial industries can look at what risk level is acceptable to them.
We have a couple of questions coming in from viewers. Where's the best place to view an aurora borealis, and during what time of the year?
Oh, what a good question. So the further north you can go, great. So Northern Alaska, wonderful place. My office mate is actually from Fairbanks, Alaska, and so he grew up seeing the aurora all the time. Yeah, I mean, of course, there's the Southern Lights as well. So if you can find your way to Antarctica, that would also be good. But if you go to some place like Alaska, I believe the winter is best simply because they don't have much daylight, and so you get the best opportunities then. Or Iceland has a big aurora viewing industry where they have guides that'll take you out as well.
Another question from the viewers: how far away are these solar storms felt? If they're large events occurring like today, would a spacecraft as far away as Juno also be affected?
Yeah, so Juno at Jupiter is inside of Jupiter's magnetic field, and Jupiter has a really strong magnetic field. And so I don't know how strong a solar storm would have to be in order to affect something inside of Jupiter's magnetic field. But if it was, let's say, out in the solar wind, you certainly could feel it. So as these storms expand out into the solar wind, they become less dense because they're expanding. But sometimes the shocks can become even stronger because they're in this less dense region. And so it's complicated. And to be honest, we don't know that well. So we're really just predicting space weather for Earth these days, and starting to look at Mars, as we're talking about sending astronauts there in the not so distant future. But space weather for places that are that far away is just really hard to predict. There's a lot of unknowns still.
Another question is, what kind of storm would it take for every country on the Earth to see an aurora?
Oh, what kind of storm? It would be extremely strong, stronger than anything we've ever felt in our historical records, from what I understand. And although seeing the aurora in every country would be really cool, we would probably lose most of our transformers and our power grids in most countries. And there's just not a lot of those sitting around. And so we'd lose all our space-based assets and our entire power grid. And so we'd have a pretty cool show for a night or two, and then it'd be pretty catastrophic for months, if not years. And so it's a pretty small silver lining in a storm that big.
Steve wants to know if you study sprites.
I do not study sprites. What a great question. So for those of you that don't know, sprites are these really interesting electrical phenomenon in the really high atmosphere. I don't look at a lot of atmospheric stuff myself, but there's a lot of cool work to be done there, and sprites are really unique.
Another good question. This is asking about previous events that may have predated the Carrington-like event.
Mm-hmm.
Are there any recordings or observations, maybe in the studies of ancient peoples, that would show some kind of an event like that?
Yeah, so from what I understand, there are some records like this. I believe Chinese astronomers have recorded viewings of auroras, things like that, for thousands of years. I might be mistaken, but I believe there's some with the Romans as well. For the Carrington event, what was great is Robert Carrington was actually observing the sun when this went off. So we were able to link it and know the exact times. And so it's certainly possible that there were stronger storms. We don't have as great of a record, though. It's just not quite as reliable because you don't have as many points to compare.
How often do you think that the Earth will be in the exact wrong place?
It's a good question. It's really hard to know. So, I mean, it hasn't occurred since 1859. So we've got a pretty good record going right now. But I think most space physicists would say it probably is just a matter of time at this point. But it's kind of like this Category 5 hurricane. You know, how often are you going to get one of those? Not often enough that you lie awake at night worrying about it, but maybe often enough that you should buy some flood insurance or, you know, build your house stronger, things like that. So you want to really kind of prepare for the worst, but these are really low frequency events.
You mentioned protecting satellites that are potentially at risk. Question refers to the ISS, the International Space Station, which is a very large satellite. How would they protect themselves and the astronauts and the spacecraft?
Yeah, so that's a good question. So the ISS, compared to some of our other satellites, is actually at a pretty low altitude. And so it doesn't face that much of a risk unless it's going pretty close to these polar regions that I mentioned. But there is certainly a real risk. And NASA Johnson actually has a space radiation team that thinks about this, and they've been thinking about this now for as we go to the moon. But they train the astronauts and talk about the radiation risk. And I believe that there is kind of this more radiation protected zone in the ISS, and that they have like special blankets to lay under. But don't quote me on this. This is just what I remember hearing.
And one last question. The viewer wants to know if you think we're in a Maunder minimum, excuse me.
Yeah, so what this person's referring to is these solar cycles go up and down and they change in intensity each time. So there's these 11-year cycles. But the strength of each cycle is not the same. And so the Maunder minimum is this time where the sun just became really quiet. It didn't have many sunspots. So sunspots are associated with activity level. And over the past probably 3-4 solar cycles, the intensity of each cycle keeps going down. I don't know whether we're facing a Maunder minimum situation. I would certainly hope not. That was pretty extreme. I don't know if this next solar cycle will be less intense than the last one was or not. I think that the current predictions show it'll probably be about the same as last one, which is it is pretty low intensity, frankly. But looking back in the sunspot records, it does look like there is kind of these multiple frequencies that exist with how strong the solar cycle is. So we'll just have to wait and see. And this is an area of science that's still developing. I don't think we're going to a Maunder minimum, but I couldn't say for sure.
Well, thank you, Rachel. We appreciate the research you're doing and sharing with us this evening. And we will forward any other questions we may get after the fact. Sometimes they start to pop up as people watch our videos as they're posted later online.
Yeah, thanks so much.
And our second presenter tonight is Dr. Frederic Allegrini, and his program is entitled The Nightlife of a Space Nerd. Frederic grew up in Switzerland, where he first became interested in space. He was fascinated by rockets as a child. While he doesn't build rockets now, he has built or contributed to a bunch of scientific instruments that are flying all across space. As a young man, Frederick's father gave him a camera and then later a telescope, and the synthesis of his interests and passions soon merged into night and astrophotography. He is fascinated by shapes, textures, and colors, and he recently started focusing on all the wonderful relationships between the things found on the Earth and in the sky. I've had an opportunity to view some of Frederick's photography online, and I invite you to do so as well. And again, we will monitor the comments sections for questions to share following Frederick's talk. So please make sure to drop them in there so we can get them along. Frederick, you have the floor.
Thank you very much. Thank you very much for inviting me, for letting me present my stuff. I'm going to share my screen and get going. Um, there you go. Okay, so I'm going to show some of the pictures. It's not really scientific, but it is kind of a hobby that I do after a long day at work. I send stuff to space, stuff meaning space instrumentation for scientific missions, and then I enjoy a little bit of the calm of the night with a camera or a telescope. So I'm going to show some of these pictures. And the theme here is mostly to put astronomical objects that we see in context with what we see also on Earth. There's, jewels in the sky and jewels on Earth. And I find interesting to merge the two. Sometimes people are aware of one thing, but not the other. But I think that actually the two go hand in hand together. So I'm going to start with man-made objects in space. We're going to stay within the solar system. I also do a little bit of astrophotography with deep sky objects, but we're going to stay within the solar system today. So here is my house. And
Frederick, we're not actually seeing your screen at this point.
Oh no!
You can go back in and see if you can share screen.
I thought I did. Oh my goodness!
Okay, there you go.
That's not very professional from a space physicist. Anyway, okay. So here is a picture of my house. And the trail that you see like a bow here is the International Space Station that was flying over San Antonio at the time. So I kind of like having these two together and compare a little bit the scales. The space station is 73 meters by 110 meters across roughly, and my house is 6.7 meters. So it's a dwarf. It's nothing. And then the space station orbits about 15 and a half times the Earth every single day. My house just makes one turn every day. And then the occupancy, we have 3 to 6 people generally in the space station. In the house here, you've got usually 4 people, 3 cats, 1 dog, and not counting the insects and lizards and other animals. But that's what it is. So I like making these comparisons because it puts things in perspective. Here is another one that's also the International Space Station, also flying over San Antonio, but this time over kind of an iconic building, the Towers of the Americas. And so this pass was about 7 minutes. It's not that long. I had to get up early one morning, but that was really a lot of fun to try to make that. And how do you do that? So everybody actually should, with a camera, should be able to get out and try to do that. It's a lot of fun. I use Heavens Above. That's a website that predicts these events. You can predict them a couple of weeks in advance, and this is really a great website. I have to just say that it's fantastic. And then Google Maps are always useful. The photographer's ephemeris is also extremely well done. And then for weather, I use Astrospheric or Clear Sky Charts. With that, then you have to go out and start practice and fail, and that's okay. It's all fun, and in the end, you might actually get something that you're proud of, and you can show around. All right, let's switch to the moon. So here I've got the moon framed with a few buildings. So it's not a montage. It's really the moon was at the place when I took the picture. There's a bit of processing. I have to say these are not necessarily my best pictures, but it's always fun to have the moon in your frame, and it's not necessarily easy. Sometimes it's challenging. The brightness of the moon compared to the brightness of what you're trying to take a picture of is usually very different. So you have to find techniques to to adapt. Okay, so let's move on. So here is one that was actually fun to plan and execute. So that's a total lunar eclipse. It was in the evening. It was January 2019, I believe, and it was so early in the evening, so that the moon would actually pass by the tower at the time. So I went a day ahead of the eclipse to kind of calibrate the whole thing, and this is the result. So I took a picture about every 7 minutes. It's 4 hours sitting on a chair and by the tower, and then you get this, and then many hours because I'm not very good at Photoshop, but many hours to just put the things together. But the moon looked exactly like that in that position at the time. And then you can zoom in a little bit and then even see some details on the moon and this beautiful violet tower at the time. And here is how I make it. So I used an app that it's called Lumos. And then you can see, you can use, on your cell phone, you can use the camera and then see where the moon or the sun will be at some time with your perspective with the camera. So that's really useful, very cool. All right, let's change to the sun now. So I always wanted to line up the sun with the Tower of the Americas, and it happens only twice per year from the vantage point I chose. And here is one example, and I believe that was in February. I can't remember the year, but it's basically to have the sun behind the tower, you have to plan that in advance. And every conjunction, if I may say so, is different. So here you see the sun pretty much at the top of the tower, and this one, the sun is right, or the tower is right in the middle of the sun. And you can see the difference in the skyline, maybe a little bit. So the zoom factor is different too, but there is a new building here. That's the one here. That's the Frost Tower that you saw in an earlier picture. So this is really fun to make. But it's also challenging. The contrast between the sun and the rest of the frame is obviously enormous, and you have to plan for that. Okay, so now I'm going to move to stars, and I'm going to start with a little bit of a story how I got to stars, because that's not necessarily obvious. So a neighbor one day showed me a picture of another neighbor that took pictures of stars from San Antonio, and I thought that, before seeing that it was not possible. It would be really difficult and not necessarily rewarding, but it turns out it's possible. And even though what I'm showing here shows that it's difficult. So the Bortle scale is kind of a quantification of light pollution when you try to look at the sky. So one is extremely dark. You've got zero light pollution whatsoever, and you can see all the stars. Really a lot of stars. And as you go up the scale, you get to Bortle scale 8. Actually, 9 is the highest. And guess what? 9 is the middle of San Antonio. That's the white spot here. And that's where I take my pictures, obviously. So you've got also the light pollution map of the US here. You see that the east part of the US is a lot more light polluted than the west part. Fortunately, in Texas here in San Antonio, if you drive a little bit west, you started seeing dark skies. Big Bend is a good example for that. So you would think that, if you Bortle scale 8 or 9, well, you're going to have a washed out sky and it's not going to look that great. But I tried, and here is one result. So this is the tower. And again, the theme here is to associate something from the sky with something from the earth. And the tower is really kind of one of my favorites because it is a little bit like a beacon for San Antonians. When you see the tower, you know you're not very far from home. So that's a nice place to try that. I'm going to send a quiz here. I'd like to see if people can guess roughly how many hours it took me to take this shot. It's multiple shots that are put together, but the whole process is counted in hours. So if you can find, you get 2 points. And then another thing I want to say here, the star that's right almost at the tip of the tower here is Polaris, the North Star. That's the one we use to find our way in clear nights if we need to find the North. And it's not quite aligned with North. It's about 3/4 of a degree away from North. But if you could imagine the circle closing here, you would be able to put 3 full moons across. So it's interesting. It's not nothing. But of course, to find your way, it's probably sufficient. All right, I'm going to show a lot of stars. So this one is one example. This is another one. The tower is a slightly different color. And here the integration time was much longer. You can actually see that the arc goes also almost half an arc here for the Polaris. So we can actually take pictures of stars downtown. It is surprisingly doable. And sometimes, well, there is some interference there. So that was actually a night I was hoping to take good star trails, but instead I got helicopter trails, which I find kind of funny anyway. So this is interesting to see that too. Okay, and this is something new, and I think I've never seen it. So I'm going to claim that I invented it, but I apologize if somebody thought about it before. But it's basically to say a message with Morse code with the star trails. So here you get an extra bonus if you can guess what is written. You have to read from left to right. Well, I'm going to leave it just for a second. You can see also Polaris here. That's just touching the top of the tower. I had to line this up carefully, and then once I had my mark, I could always guarantee that. And I could not put the light in the middle of the circle because otherwise the tree would have hidden the tower, which is not what I wanted. Okay, so moving on. Tower is fun, but what I enjoy most is putting public art displays in the context also of astronomy. This is a beautiful piece on the south side of San Antonio by Mission Espada. Again, a quiz question. This is a tricky one. If someone can tell me the season when I took that picture, then you get really like 5 points. There you go. And the moon helped a little bit. Taking this shot, you can see the reflection of the moon at the time on the structure. The structure is composed of 700 clay pieces, clay structures. And the artist that planned this wonderful piece is Margarita Capera. Here is maybe something that I couldn't miss. I love the Torch of Friendship in San Antonio. It's a beautiful piece of art. And then the River Walk. The funny story about that is that it was during the first lockdown here in San Antonio, so a year and a half ago, roughly. No, actually, a little less than a year and a half ago. And the River Walk was not very busy, so that allowed me to take this picture. And then you've got these nice trails in the background. So it seems a little bit unusual because it is so quiet and so empty. Here again, the Torch of Friendship. This is maybe also one of my favorites. I do love the colors, the mix of the blue and the dark blue and the red here. And then somehow, the Earth rotates while this thing stays solid and in place. And then also one of my favorites is the Confluence Park. This structure is absolutely gorgeous. And they had the good idea to line it up with also the north. So I'm sure it was on purpose. This is actually a structure that collects water in tanks, and then that the water can be reused to water plants. I encourage you to go. This is on the near south side, Confluence Park. Absolutely gorgeous, and especially at night or in twilight, during twilight, it is really beautiful. The lighting is perfect. And so now I cheat a little bit. I'm going to show planets. The reason I do that is because it was recently in the news about 4 months ago. And so I'm not associating this with something from the Earth, but I thought that, people from this audience would appreciate seeing this sequence. So that was the dance between Jupiter, or the rendezvous between Jupiter and Saturn that occurred in December 2020. And yeah, I had to practice over many days and to try to get the right shots. All these pictures were taken with a single camera. It's not a montage. It's not taking one planet and then the other and then putting them together. It was really on the same frame. There is a little bit of work to get the contrast and the brightness of these planets the same, but it's really minor details here. And then you can see it, they're getting closer and closer. And then for the last day, I had to travel 5.5 hours north to get a cloudless sky to see them at closest approach, which you can see here in zoom. So you can even see some details on the planets. You can see the moons. Don't ask me which moons we're seeing right now. I don't know. Maybe this one I do know. This is Titan. And this is Saturn. Now, I just want you to pause for 1 second, or maybe a few seconds. Imagine the scales of these things. So the planets are gigantic. The Earth compared to Jupiter is just a dwarf. It's just a little, it's almost like a pebble. And Jupiter is about 5 times as far from the sun than the Earth. And then Saturn is about 10 times as far as the sun. So the distance between between Jupiter and Saturn is about the same as between Jupiter and the sun. And yet they are on the same frame, in the same field of view. And these are absolutely enormous in space. If we could just travel around them, we would just be completely in awe. So just thinking about the scales for a second, for me is really almost breathtaking. It's very, very impressive. Plus, I spend a lot of my daytime working on Jupiter, so that's also super cool. And that's it. I'm at the end of my presentation. So thank you for watching. And if you want to follow some of my pictures, you can go to either Instagram or go to my website, and the names are down here. So thank you.
Thank you, Frederick. And we have a few comments from our viewers. Reflecting on that very last image, I'll share that Michelle Rissy went into our observatory the night before this occurred and was able to get a nice clean shot like that. And when we posted it on Facebook, it was one of those posts that went viral. It was like almost 800,000 people who looked at it at some point. So this was a real high profile. A couple of questions, actually a lot of guesses on the questions that you asked. Delilah said for the first image that maybe that was 10 to 15 hours. Andrea said 10 hours, and Patty suggested 24 hours.
All right, so interesting guesses. I was not as patient the first one. So I think that's the first one, yes. So that one was roughly roughly 3 to 4 hours. And you can tell because, so if it was 24 hours, the stars would make a full circle. So basically, the Earth would have rotated completely over the 24 hours. So it is not really possible to do that here because there is daytime, and then we could do that on the in the North Pole in the winter, for example, but not here. And then the way I can guess is basically a full turn is 24 hours. So this is maybe about 3-4 hours. But there was good guesses, I have to say.
A guess that was given for the Morse code was, does that say the stars at night?
Pretty cool. That's not too far. Should I just give the answer?
Yeah, that's the only guess I had for Morse code. Not too many people out there.
So it starts with an A and an S and then T, R. So it's astronomy on tap.
Very cool. Very cool. That could be the mantra for this program.
Maybe.
A couple of questions unrelated to the photographs there. What would you recommend? What would you recommend where a budding astrophotographer to start, and what would be the best kind of equipment to start with?
Oh, that's a great question, but it depends on what you want to do. So to do what I showed today, you only need what I use is a digital camera. So it's probably better than more simple cameras from your cell phone. But so you need a digital cameras. You need probably a tripod, and you can do things like that without any fancier equipment. I do use also filters, but it's not necessarily the case for all the pictures. Now, if you want to start doing astronomy or astrophotography, where you start having, again, I lied, I think. If you want to do that kind of astronomy here, you need a pretty big telescope. And I used a digital camera for that, but you can have specialized cameras for deep sky objects, so things that are a lot fainter and then come that you have to take pictures for hours before you can get something usable. So telescopes, there is a big range in cost and in performance. If you're starting, I would not spend too much. But one thing is important is the mount is as important as the rest. If you don't have a sturdy mount, it's going to be difficult to do astrophotography. And then there's so many good websites and people helping online and clubs of experts that if you're a little curious and you're willing to work hard, this is really, really rewarding hobby and a lot of really nice people that do that. And it's not a competition. It's really all fun.
Christine wanted to know how long it took for you to develop the skill level you're using to get these.
Oh, it's embarrassing. Too long. So it depends on how much time you spend on it and how often you're willing to go out and spend the night out and still work the next day. It's not necessarily easy. And sometimes the weather is not helping. So I started maybe more seriously, maybe about 10 years ago. But I have to say, I go out, do astrophotography only, so this kind of stuff here, only maybe 10 nights a year at most. I do a lot more of the San Antonio stuff with stars, maybe multiple times a year.
We have had conversations at Scobie with some of the biologists in the area who were concerned about Starlink and the effect on migrating birds and other animals. We have a question from Tracy that wants to know if you believe spacecraft like Starlink or an abundance of other things in space may actually impact your astrophotography.
Yes, they do, and they did. So I'm going to speak only on my behalf and not on anybody else's behalf. This is my personal opinion. I really don't like them. um, I think this is really not fun for astronomers. This is really not fun for our dark skies. I don't really see the need, but maybe I'm a little selfish and I want to have my dark skies. But I don't go out very often to take pictures, and I was hoping to get one night the Orion Nebula that I've been chasing for many years. And so I did that. I spent the entire night out, came back home to find that I had Starlink trails on every single image. So that was not a good day.
And that's I think there's a whole nother new program of scheduling to launch them in greater numbers to see how often those boosters will run. That was in the news today, I believe. Christine has another question. She wanted to know how long you set the camera out. Do you put your camera up and leave it somewhere safe, or do you stay with your equipment all that time?
I usually stay with my equipment all the time, especially if it's in San Antonio. But if I go out and camping or in the middle of nature, that's okay. I can leave the camera out. I also tried to do wildlife photography at night, where I have to get away from my camera. I have a little chain to secure it inside the box, but no. But usually I stay within reach of my camera.
NASA has a web page they call Astronomy Picture of the Day. It's pretty popular, and several times they've posted images from different photographers who have caught the International Space Station either in front of the sun or the moon. Have you ever contemplated trying to set up that path?
Oh yes, absolutely. That's on my to-do list. I haven't been able to set this up, but I see that almost daily from people that post these kind of movies. I think that's fascinating. I love the idea of taking that.
And related to that question, 2023 and 2024, we are the only area in the entire country where both the annular and the total solar eclipses cross those paths. Are you planning ahead for your photography moments with the sun?
Oh yes, I haven't started working on it, but I am definitely I will be on the path of both of these eclipses. I didn't show well, actually, you know what? I'm going to show it regardless. Here is the 2017 total solar eclipse. We had to travel at least 2 days to get to see that, but that was a fantastic event. I recommend everyone who has never seen a total eclipse to really make the effort to go on the totality path and experience that. This is the same. If you go outside the totality path or you go inside, this is like winning $50 or winning the lottery. It's really a world of difference. So you really want to be there. This is a magical event.
Well, we're going to take part in a Saturday event for the annular eclipse at Scobie, but we are sadly at 97% of totality in April of 2024. So I know that my staff is pushing west. I know you can go as near as the rim, that portion of the city, and be in totality for a couple minutes. Fredericksburg and those folks get like 4 or 5 minutes. So there are some of the extended time periods. All right, are there any other last questions that are posed by our viewers? Okay, well, at this point then, huge thank yous to both Frederic and Rachel for your presentations this evening. We expect to be virtual again in the month of May on Wednesday, the 26th. So Scobie should be hosting again at that point for Astronomy on Tap. And then we'll give you updates as we get them from the organizers as to whether or not it'll be returning to the Blue Star brewing company when we come around to June. We invite you and your family and friends to join us again at the same time and these same streaming locations for the next edition of Astronomy on Tap San Antonio. And we'll celebrate the amazing work of 2 more scientists. And we'll, of course, toast to the heavens on those evenings. So again, many thanks to both Frederick and Rachel, and have a wonderful evening and even better tomorrow.